Hello and welcome to CodeWeaver Writes Code. Yes, we're going to be doing some more Rust mostly, and some exposure to C++ and Haskell and a couple other things depending on how I feel. And now I can take off my headset because I can tell that my audio is going through reasonably well on the stream. Perfect. Okay, so I don't need that on my head anymore because I don't need to listen to game audio or anything like that. So let's switch right over to the code. Yeah, so actually switching right over to the description of the problem, which I'm not going to read through, did that on the very first video in the stream. You can pause it and take a look if you like. Also, a reference to the puzzle that sort of sparked all this off, and the very brief version of this is the very first puzzle in the advent of code. Let me see if I can actually fix up the overlapping of some of these windows a little bit, because that'd be nice, so you could actually read a few things that were actually on screen. So let's take a look at that. Did that help out at all? Possibly. Yeah, something like that. Anyway, it doesn't really matter because this window's going to go away in a moment anyway. The idea was that when I was writing the solution to this puzzle, the solution that I went with, it basically involved traversing a list and the reverse of the list, or a list and a list backwards, whichever way you want to look at it, in order to match up pairs of values that added to a specific value, having sorted the list, because that's how you solve this kind of puzzle. Spoilers, too bad, now you know how I did it. Not a very complicated puzzle as such, but the point is that I recognized that operation of processing two lists at different rates was something that I also used when writing one of my favorite quick little snippets, which is merge sort, which I was doing both of these in Haskell at the time. And the merge part of merge sort is kind of a neat little function to write because it's relatively simple, but it's got some nice recursion in it, and it just makes me super happy. But the problem is, or the thing was that I noticed that those two operations both processed lists at different rates and then took pairs of values, one from each list, and did something with them. A close cousin to this would be your typical zip or zip with, or comes under a couple of different names in different languages. You see it as transform, or one of its variants anyway, in C++. You see it as zip in link for C#. And you see zip and zip within Haskell, obviously. There's a built-in zip that's inside Rust. So, so pretty common function. And I wanted to be able to try to do this version that would suffice for merge and the searching part of the sum to end puzzle, which we're now going to completely ignore because we're not going to look at the puzzle anymore because that's not really the point. So we're going to turn that off. We're going to turn off the description of the stuff. Oh, except that actually I can turn that back on so that I can show you very, very briefly as a summary what the Haskell version of this ended up looking like. And there it is in all of its glory. That's all it took for me. And you can actually see a little bit lower down here. I describe my own version of zip, which defaults to, or is based on my own version of zip with, which takes an arbitrary function to do the combining, and that itself differs off into the function that I intended to write. And the idea here basically is that I do take pairs of values from each list, except one of the return values from the combining function is also, if you've done the combining, what to do about the lists. Either advance the left, advance the right, advance both of them, or come to a screeching halt. And there's also separate functions for dealing with the tails of the remaining lists when one of the lists runs out. And this works just fine, right? It's half a page of code, less than that actually, if you get rid of all the comments. So yeah, that worked out pretty well. I said, well, okay, I did a version of it in C++, I did a version of it in C#, and they both are implemented slightly differently because of the way they handle iterators and laziness and so on. For example, in C#, I could get away with using the IEnumerable mechanism to do a lazy iterator, which means I could yield, it has a continuation mechanism so that I can yield a value out of the middle of a function and then proceed the next time somebody wants a value. That mechanism is quite handy. Haskell, I can do something similar because I can add onto the end of a list with a thunk which evaluates in the future, so that I can effectively get the same effect of yielding a value out of the middle of something. And in C++, I did something kind of similar to what I'm doing in Rust, except that I did it with pairs of iterators because I wasn't using C++'s range. C++20's range mechanism, where they went to something very much like C#'s link, where you can get views onto collections that iterate a lot like Rust's iterators, and you also have to reify it at the end a little bit like Rust's iterators and C#'s iterators. So I did not use C++20's ranges. I may do that eventually as an alternative, but using its pairs of iterators that it uses in its standard collections prior to that, I implemented a version doing that. But I'm not going to show those right now. You can go back to the other series, the earlier ones in the series, to take a look at that sort of thing. But I wanted to show this because this was the inspiration. This does, in fact, correctly handle the two cases that I originally set out to do, which was to be able to implement merge with it and be able to implement the part of the puzzle which generates the sum to ends, and actually this generates all such pairs out of a list without duplication, I think. And then I can filter this down to grab just the first one if it exists, and then multiply the values together like the puzzle requires. That wasn't the part of this that was actually interesting to me, the final part of the solution. At this point, it was just the part of it that needed to use my iterator, or whatever you want to call it. So we are now down to the Rust. So we're going to ignore the programmer's notepad stuff. It's going away. The Haskell stuff is going away. And we're back to Rust, and we're back to where we were yesterday. So let's pick this right up where we left off, sort of. So I had some time late last night to sort of poke at this on my own, to try to figure out where I wanted to go with this. I had to move, you can look back at my original code, I had to move a loop out to encompass more of the iterator. I had to take into account more test cases. What I came up with, actually, was I'm going to go all the way to the top. There's a lot of test code here. This commented out block here is largely what I wanted to do. And that's that every time I was asked for a next, I would loop until I could find at least one valid value. And this helps me filter out any return values where I say keep processing the two lists, but I don't have a value for you at this time. So this allows me to do some filtering. I've thought about taking the filtering aspect of this out of it, and a version of this I may eventually implement would be more efficient in this loop when you don't need filtering, but allow you to filter it like outside this loop, like put the onus on the caller to filter out effectively empty values. A skip, if you will. I have a skip mechanism in this to say I don't have a value for you. And that just came out largely as a result of me using this tuple type here to say what to do with a step and an optional value. I could have combined these, so let's not go into my design. But the basic idea here is I keep looping, and as long as I have two values, when I try to do, let's see, if I have no values available, I just break out. I'm totally done with the outer loop, and I return a value saying I'm kind of done with the iterator now. And the other way that I can look at this is that if I have some value in either the left or the right halves, the left or the right lists, I have some kind of value that I can peek into, then all I do is I unwrap the value that I get out of the only remaining list, because the other one has no value in it. And I call the function to generate myself some output, and then I say if I'm meant to halt early, then I just do the same thing as I did up here, halt everything. Otherwise, I just break out and return the value. This break value syntax basically results in a value for the outer loop, and that's been a really helpful mechanism here. Got lots of different ways this could be resolved, but that's the way I chose to write this code. I'm just learning Rust. So, yeah, and then the final case is the most complex, is where I have values in both lists. And at that point, I'm either asked to step both, step left, or step right. And in either case, what I do is effectively the same thing. I have acquired the... sorry, where does R come from? R in here is coming from the... I match against the function call f2, which is a 2-parameter version of the functions above. Could have called it fxy, I suppose. This value gets captured as R, and then I just return R. But before that, I advance one or the other stream. And I have to do this manually because up here I could just do it by, at the same time as I was doing the match. You can see the next here. But in this case, it may be the case that I only want to advance one or the other iterators, so I couldn't do the next up in this match mechanism. This basically compiles, except it depends on a few things. I pretty much believe that the idea behind this will work. The biggest problem that I have is when I tried to tie my zip function into this and my zip width effectively, the same way I did in the Haskell version, I ended up with problems with regards to stashing stashing the iterators in here because of the way I was trying to... Actually, not stashing iterators, stashing the functions. Now, the reason for that is because it is actually... I don't actually need that comma there. Kind of harmless, but there you go. The reason for that is going to become apparent in a second. But basically, the idea is that I was trying to make sure that these functions all obeyed a certain signature. They all basically... they all basically produce the same trait, which is true for a function that comes from a function pointer. It's true for a function that is a lambda, and so on. They all implement this trait, but I was having difficulty ultimately stuffing those into the structure without resorting to putting stuff on the heap. I wanted to do this entirely without pointers. That's very, very tricky because if the only thing I know about a type is that it is a trait, if I try to pass it in as a trait object, as it were, they are not sized. And you need, in order to have it embedded in a structure as a common type, it needs to be sized, apparently. That doesn't mean you can't necessarily put these things in structs, but you have to be very, very careful how you do it. And I'm running into type unification problems, which I'm going to illustrate in a moment. That was a whole bunch of babble, and if you don't know what I'm talking about, it's probably because I don't know what I'm talking about. I'm taking a lot of this from a combination of my C++ work with generics, with templates, where everything is very much more duck-typed. And there's a few more features with regards to type deduction that I have there than I do in Rust for reasons. And stuff I'm gaining from Haskell, where I often don't have to worry about the difference between heap values and stack values because that choice is taken away from me effectively, for the most part. Most of the stuff ends up effectively on the heap. It has a very, very fast garbage collector, so it just handles that. Yeah, so where does the problem come in? Well, so where does the problem come in? Here's the thing. Instead of working on the version of my zip that was ultimately going to fob everything off on my personal version of merge zip width, or my function that I'm actually writing. What I'm going to attempt to show is that this working implementation, which you can see the run and execution on integers down here for zipping, probably does not work as a generic mechanism for functions in general. And the reason for that comes down to, see if I can point to where this is starting to fail. So, so this is all in service of zip. What I really want is to show the version that, this is not the version I want to show because this is all self-contained. This version of zip simply builds up tuples directly. There's no lambdas involved here. There's no attempts to have an abstraction on functions here. So this is actually not the version of zip I'm going to use. The one I'm going to use is this one here. This is the one that actually fobs the problem of zipping off onto my zip width. And the way it does this is it actually builds up, even the version of zip that I have builds up effectively a my zip width iterator, giving it the function to do the combining in terms of tuples, because there's no reason why my zip should not be able to do this. This is a perfectly reasonable thing to want to do. In order to make that work, we are going to use the version of I need a version of my zip width, which is here. And its associated zipping structure. So I'm turning back the clock, as it were. I'm not going to work on my merge zip width. I'm going to work on just my own version of zip. That is, I'm not actually looking at, or I'm going to try not to look at much, the implementation of zip in the actual library, because I want to try to come to the same conclusions myself. So what do we have here? We effectively, well, first of all, let's see if this builds, because I haven't actually had this combination of items done. Yes, it does build. And if I run it, takes a moment because I got to tell my virus checker not to actually continuously scan those folders, but what do you do? There we go. So it works just fine. And the way this works is effectively my zip here calls my zip width and provides it a function. Right? Just provides it, well, provides it a lambda. Right. Perfectly sensible, correct? So what and that ends up doing then is it calls this function here. This ends up being the left-hand side, the ix, the x's. This ends up being the y's. And I have labeled these badly because I've changed everything to x's and y's everywhere else in this code. So maybe I should take a moment and actually just clean this up so all of my implementations use the same descriptions. I'm going to do that, and then you can see what happens. But basically, I pass in my x's and y's here. I pass in the function to be combined here, to do the combining here, and then I build up the structure that is going to be used as an iterator here. And the actual data for that is here. And the data that I need to do this operation are the two iterators, the function to do the combining, and why do I need ix and iy? Hang on a second, let me double check this. This is just constraining. These are, these are the type constraints. A is an iterator, B is an iterator, and F is the function, and here are the values. I just need the two iterators in the function, right, in principle. So let's just clean this up here, because I've actually called these x's and y's elsewhere in my code, and I called this the return value. So let's get all of this nomenclature consistent with the rest of my code, because x's, y's, This is a very Haskell thing to do. But that's just going to help me maintain consistency in my thought process with the rest of my code. So this is going to be x's items and y's items being taken into this function, producing a return value r. And now that's working. And now let's just clean up this and this. And then the iterators and all of this stuff I can now paste into here to clean that up. The iterators, the implementation of iterator for this type requires me to identify an item to be consistent with the rest of them. So you can always ask an iterator as a subtype what its item is, which is just the return value of the function. Because I'm not doing anything funky with optionality here. Yeah, no, there's no filtering going on here. So, and then in the function, I just got to make sure that I am stating this correctly. Self, this is x's, this is y's. That's fine. I got to change this, and this is the trait that says that if I'm myZipWithable and I have an the templated type is an A, which is an iterator, then this is going to be x's. So the trick for making this apply to all iterators. Y's function return value. This is y's. That's fine. X's, y's, f and r. All right. And actually, technically, this could probably be self. But let's not change anything I don't have to just yet. So that's R. See, a lot of my template parameters are actually attached to the function and not to the trait or the implementation. The idea here being that the trait's only distinction. The only distinction that I want to define this trait on is the iterator here. The rest of these I want to define specifically when you're making a function call, so that this same trait is what is used to be able to allow calling of multiple ones of these items. Now, I don't know if this is a sensible thing to do. I'm still trying to get a handle on when I want my generics part of the function and when I want a part of the trait. But for the moment, this is how I've done this. Okay, so that's YFR. So self, this is Y's, F and F, where Y's is an iterator, and this returns R, and I think I've almost got this refactored. I do not have this refactored. Type annotations needed. Okay. Cannot infer the type for type parameter XS. Why is that? What have I gone and done? Quickly doing a big ass undo here. Pardon my language. All right. Make sure. So that has to be R, and that has to be X's. That has to be Y's. and that has to be wise. Type annotations needed. Iterator. I thought I had this actually already defined. Why is this a problem now? X is Y is F and R. Y is here F. X is item. Y's item produces R. Why is this an issue? Aside from the fact that I haven't actually completely done this yet. All right. There we go. Okay, so some of those errors were erroneous. I do actually have to do a full build in order for it to apparently clean up all of the errors. I haven't quite figured out how to get VS Code to do everything as smoothly as I'd like. So this is back up to running, but now the items, or at least the elements in that code, the generic types have been listed correctly, except it isn't here. So let's go and do this. Interestingly enough, in this, I have not actually put the type annotation down on the function. So let's see if we can clean that up too after I do all of the appropriate substitutions. XS, YS. I promise I'm going to get to the pertinent issue here fairly shortly. X's, Y's, Y's, X's. Actually, sorry, this is actually Y's here. So that's Y's. X's is coming in from the outside. Self is effectively this trait, but not X's specifically. So that's fine. That's self R. That's self R, that's fine. And I think, right, Y's. All right, quick little refactoring job done. So I'm talking apples and X's. Let's just make sure my stream is still running. Yep, okay, so, Right, so the problem comes in as to this. I basically discovered that one of the reasons why this works in its current form, why not, we'll just run it in the background while we're waiting, is because I'm able to return this function, I'm able to return this, this type, my zipwidth, by providing it in place of the one function that I need to pass into it. Rather than passing in a lambda, I'm saying that I'm actually able to pass in a function pointer. This is how you basically state that you want a function pointer. And you notice the lowercase here. So this is not a trait. It's not bound by a trait. It's bound by a function pointer. Now that gets passed off into the myZipWidth struct, and we can see that the myZipWidth struct says that the type for that third item has to have this trait, which that function pointer does. And so I'm allowed to build one of these with one of these function pointers, right? And that's fine. So, and a function pointer is a known size at compile time. So I'm able to build one of these structs and everybody's happy. Right. But because what I want to be able to do is I want to be able to pass in any kind of lambda into this, I want to make sure that when I build one of these, return and build one of these myZipWith structures, which holds the data of the iterator so that the methods of the iterator can do the next thing and keep advancing things. This type is being specified specifically with a function pointer and not with any sort of trait. And it's like, okay, when I wrote this, it's like this actually works pretty well. I did exactly what it said on the tin. When myZip gets called, it calls myZipWith, provides this, which got passed into me, but supply the function that does the actual work. Now here's the thing. This only works because lambdas that do not need to capture state, closures if you will, they do not need to capture state of any kind. They don't need to capture anything from the outside world. They just need to be able to take parameters and return a result, can be turned into a function pointer of the correct type. And so when I go to call myZipWith, the return value of this is exactly what I stated. It is one of these. And that's great, right? That's great. I'm basically just fobbing off my responsibility on the higher order function. I pass in one of these, which happens to match the rate parameter, and Bob's your uncle. That's fantastic. So here's the problem. If I were to have another version of this, where I was going to say, so this is no, we don't need to do this. Actually, we can just put it in here. We'll just have a myZip. We'll have another function. Totally have more than one function as part of the implementation. But what we're going to do is say myZip plus, which is not really. This is actually more of a dot product. So, but we're going to call it myZip plus. Well, it's part of the dot product actually, or myZip times would be, I suppose. Sure. Let's actually do this myZip times. And what I'm going to do is, instead of binding it, no, this isn't going to prove anything either because I don't need to capture outside stuff. So what we're going to do is we're going to do something called myZip scale. And so what we're going to do is we're going to pass in an extra parameter, which is basically just like an int. So it's going to be like an I32. No, that's not going to be any good. The reason that's not going to be any good is because I don't know that x and y are necessarily ints. Let me think about this for a second. I need to be able to capture a thing here and have it operate on this. So, don't know that these values have any operations I can do with them other than just store them, because I haven't restricted what the types of x and y are. It's the best way to prove the point. I guess the best way to prove the point is to I need to be able to I need to be able to capture a value. How do I produce another value that I can capture? Okay, here's what we're going to do. We're actually going to here's what we're going to do. We're going to say we're going to take in a y, just a single y. And what we're going to say is this is actually going to be zip common y. All right? There's no reason we can't do this. And so what we're going to do is we're going to say, except we still need to have the y's just to make it the other part of the list. So actually what we're going to do is we're going to cheat. We're going to call, we're going to use S, we're going to use, and we can't use self here. How am I going to prove this? How am I going to prove this? All right, here's what we're going to do. We're going to have a wise. We're trying to do this without actually introducing any other constraints on X and Y, because that just complicates the issue. So I'm going to pass in a common item here, because I'm not implementing. How do I want to do this? We're not going to give this a parameter. We're actually going to ignore this, or we're going to call it Q. It really doesn't matter, because what I want to do is I want to actually capture the common Y. Is it even going to let me do this? So method is not a member of trait myZippable. All right, so that's fine. I can totally make a version of this up here. So because this is not just an implementation for a structure. It's not a method for a structure. It's actually a method for an interface / trait, right? A type class in Haskell. Using interface very, very badly there, but suck it up. All right. So, no, please go away. There we go. All right. So here is ultimately the problem. We are still, so let's just keep this in mind. What I'm doing here is I'm effectively ignoring Y's. I mean, I'm passing it in, but for each value that comes out of Y's, and that goes into Q, it just gets thrown away. So each value of this that gets zipped up goes into Q, just like each value of the X's goes into X. But then I'm ignoring Q, I just don't care. And I'm basically just substituting in this common Y that's getting passed in as a third item. So for all intents and purposes, Y's is irrelevant except that it makes the myZipWith function work. That's not the problem. This, in fact, should work, because all I'm doing is I'm saying, give me 2 parameters and I will give you the thing I want to build. And I'm allowed to capture values from an external source. Now, ignoring the whole issue of borrowing, borrowing versus copying versus mutability, all that stuff, ignoring all of that for the moment, I should be able to capture this, because I should be able to say, like, I'm basically owning whatever is passed in here. And so I'm allowed to pass it off as a moved value. Expected function pointer found closure. So the problem here, so closures may only converse to fn types if they do not capture any variables. All right, so basically I have to actually make sure that I'm regularly passing off this value in here. I might have to do a .clone in here at some point. I'll have to think about this, because these are captured by reference. Let me think about this. These are captured by reference, but then I think the zip is doing a, the ZipWith is making a copy somewhere in here. I will have to check how I do that. I pass that value into the function, which then promises to return an R in some way, given the items that it's given. All right, so hey, hi to whoever showed up on the stream. So the problem here is that, and the compiler kind of illustrates this. I'm just going to hang on. I got to turn off some volume that I got echoing going on in the background here. So the problem here is, because I'm capturing a value, closures can only be coerced to fn types if they do not capture any variables. So yeah, and Y is captured here, because this is the common one that I'm sticking in the second slot instead of the one that I'm passed in. The problem is that if I start converting these over to the trait types to say, I need to instantiate one of these, like the return type for my ZipWith has to involve basically anything that contains any type that can be described by this trait. right? And it doesn't matter if I just shorten this to like f. I still have to then say what f happens to be, which I'm not specifying here because my zippable does not contain my zippable does not contain an iterator, does not contain a generic type that corresponds to f. Now I might be able to get away with an f out here, perhaps. But the problem is then it's not auto-deducible by anything. In order for it to be up here and me not have to specify it manually, it has to be a part of a function or something else that can help the compiler automatically deduce what it is. For x's and y's, the x's comes in by way of self, ultimately. And the y's comes in by way of this parameter here. So nothing comes in to help describe this function if I just relabel it as f. I could put in a where to define what f's constraints are, but it's still not actually listed anywhere. If I try this, so what does this say? This actually says I cannot find f in this scope. Help, a trait with a similar name exists. Fn, that's fine. I could say that to put f in here and then have it constrained to be such that if I did f here and I did where f is neither of these are allowed because these aren't being provided from anywhere. Not in an automatic type deduction from an automatic type deduction point of view. So I can't do either of those, and if I leave it as that, the big problem comes in that it says the size for values and it's saying that this should be dynamic cannot be known at compile time. And it doesn't have a size known at compile time. Basically speaking, because this parameter isn't bound to a type being that is automatically being deduced, it has to stand for anything. In fact, I'm using this in place of a type. I'm using this entire trait in place of a type, and in order for that to work, I have to start looking at DIN dynamic types, which I think boil down to putting something on the heap as an abstraction, or I have to use a boxed type in order to wrap this trait. In fact, I think I need a box type in order to wrap it in anyway, so maybe that's just saying the same thing. But basically speaking, I don't have a concrete type here. Where does this type come from? Well, ultimately for me, and this occurs down here as well, I've done it's basically in both of these places here. This type actually comes from the type of this. This trait comes as a consequence of the type of this. This is the correct trait type, but by the time I get down into this code, I've already locked in what this thing is supposed to return, which I can't do because of the sizing problem of using trait objects. What I would like to be able to do is I'd like to pass in a concrete type here. I'd like to pass in either a type that comes in from the automatically deduced types from up here and the parameter lists, or I would like to be able to find out what the true type of this thing is and pass it in here. Now, there's a couple of different concerns here. One of the problems is that the type of every lambda that that captures something, and I'm going to say this more universally. Every lambda, every closure that Rust produces at present, or at least from my understanding of the reading so far, produces a unique type. Even if they have exactly the same signature, they all produce individually unique types. It's not a knowable type. It's not a type you can type out like a myzippable, or not, yeah, not the myzippable, but the myzip, the actual myzip structure, the myzip with structure. Where is it? Where did I put it here? This guy. Given the appropriate parameters, that is a proper type. There's a nameable type, and I can actually type it out on a keyboard. There is no such thing for any lambda, closure, although with the one exception that if it doesn't capture anything, it can be then converted to a function pointer type, which is why this mechanism works, and because this is an actual concrete type, given that x's and y's is defined by type deduction. Where does that put me? Well, the problem is I can't know the type that I want to give to my zip with until here. At which point, actually, my zip width would then take that parameter and perfectly happily pass the check here, where it says that third parameter has to be some generic type, because I have that generic type here, and it has to be constrained to this. Now the lambda will fit that constraint. I keep saying lambda and closure interchangeably. I apologize. I know there's some technical reasons why they're not identical, but for my purposes, just ignore me. Just treat them as interchangeable for most of my discussions. So it passes the constraint check, which is fine, which then means that the function can be called, and it also means that I can produce this, and it's happy. This value corresponds to what I want to return from this function. I'd be perfectly happy for that value to be returned here. For that return value to be returned, it has to, of course, match with this, but it doesn't, because this is specifying that third parameter is not the unique type of this, but it is in fact an abstract. It's a trait type. It's a trait object. Because that's what I specified here. Because when I use a trait in place of a concrete type, it is not a type. I guess it gets implicitly interpreted as a trait object. So that is what the compiler, I believe, is complaining about. I can't get at this type until here, and by that point it's way too late for the Rust compiler, because it needs to know what this concrete type is ahead of time. Right. This is exactly the same problem, actually, that you see in C++, because C++'s lambdas have exactly the same property. They have the property that effectively, if you capture them, if you capture any value that is not part of the parameter list, it's not convertible to a function pointer, same thing, and it is in fact a unique and unnameable type. And so, in principle, C++ would have exactly this same problem, I believe. The way they get around that in C++ is to do this. We're going to comment out this. They would basically do something akin to an automatic return type. And in this case, what would happen is that it would defer understanding what this type was and deducing it from the return values. And so when I call this, just like before, this gets passed into the other function, to the myZipWidth. That gets accepted as a type, unnamed type, but a type that fits the constraints of that function. It is therefore able to build the structure. When it gets returned, that structure has embedded in it a type that is unnameable, which effectively makes the entire structure unnameable. The entire type of the structure as to be unnameable, right? So that I have an unnameable type as an element of a structure, and so the whole structure's type is effectively unnameable. But it doesn't matter, because this then gets returned, and the automatic type deduction says, okay, well, that's just the type of this function. I'm sure that makes the compilation process tricky, because then the Rust compiler would have to basically defer processing what this actual type is until it goes deeper. Like, it would have to delve deeper, it would have to analyze deeper in order to find out what this thing's actual type was. And this actual type is unnameable. I can't name it. It is not this in any sense, precisely because the only thing that I can pass in there is a trait. So I am a little bit stuck. Now, there's a lot of course, there's a lot of documentation on how to do things like store iterators and the like. One of the common ways to do that is to store it behind a box trait object type. There's a couple of other ways to do it that even allow you to treat effectively the object as only the item that you want to store as effectively having only the properties of the trait that are knowable, and nothing else about knowledge of the type, which might actually suffice here. And a couple of those properties, including a couple of properties of doing it that way, is that iterators that, as long as they can produce the correct output, could all be considered homogeneous and stored in a vector. For example, you could have a vector of iterators that are all bound to different functions, but that are all considered the same type because they have the same signature. Because lambdas, the captures that lambdas do are not part of its apparent function signature, but they do make it a unique type. In fact, that's basically why they have to be unique types. But I don't necessarily want to hide. There's a couple things here. First of all, doing anything through dynamic dispatch in principle slows things down. I want to see if I can avoid that. If I can't, well, that's fine. I can. It's not like my C# thing is devoid of some runtime abstractions as well, and Haskell does a bunch of stuff through its own kinds of dictionaries. So I'm not really biting myself in the foot by going down some of the dynamic routes for handling iterators. But in my C# version, I can get around this because of that auto. Which makes everything compile time, even though what it ultimately means is that the return value is an iterator, effectively an iterator of an unknown type. I wouldn't be able to store multiple of the same. I wouldn't be able to store iterators constructed with what appear to be identical lambdas, even though they're technically not the same type. It would make them two different iterator types. It all boils upward. It would be an iterator of unknown type, a compiler-only known type. But for the most part, I'm just using this in a daisy chain of iterators. Is this the Rust way? Tough beans. This is what I want to play with in the type system. I don't really care. Eventually, I will get this to work mostly like Rust iterators. But I'm exploring the type system here, so. Which is funny because I really haven't mastered, if I'm perfectly honest, even layering traits on top of one another, and for that matter, the borrowing and mutation stuff I still haven't got 100% handle on. So I'm kind of jumping ahead in the book because this kind of stuff is kind of where my interest lies at the moment. It's ironic because the one thing I love about Rust that is unique is its borrow and mutation mechanics. But that being beside the point, I can't do auto. There is not, as far as I know, automatic return type deduction. The closest that I've been able to see that might work is where I can say something like, as a return value, impl iterator, because this is in fact an iterator. And I can basically get rid of all of that, except this may not work because impl trait not allowed outside of function and inherent method return types. Yep, so there we go. One of the restrictions on this I should actually go and read up lots about how to the standard ways to manipulate or to implement iterators. But one of the problems is this the ability to return an implementation of something isn't really much different, I don't think, than... No, that's not true. The whole point of this, having read one of the RFCs in Rust about this issue, was that this was the way to attempt to return a concrete object of an unknown type, like something that could be efficiently processed. Although I seem to recall that the return value of this kind can't be stored in a structure, which doesn't make it ideal. Like, I kind of like the idea of it being a data value. So I can't do that either. I need a way to stuff into this spot right here to make this a truly universal zip. To say nothing of my merge zip. To make this a truly universal zip, what I kind of need to be able to do is to be able to give the real type of this to this, which I can't do. Yeah. I don't know the type. It's an unknowable, writable type. Writable is a bad word, but I can't state its type, and I can't get at its type ahead of time. I couldn't even do, in principle, because in C++ I can get the type of an expression using something like a decal type. I can't even do this. Like, even if this were legal, Rust, I wouldn't be able to do this, because the version of this that's in here, even though it has exactly the same signature, well, first of all, it's trying to capture something that's not even legal here, but even if it could capture something else outside, it wouldn't be the same as the one in here. Like, if I actually turn this into a Y and a Y, these two things are still not the same. It's the same type. The same signature, they implement the same, effectively the same function trait, so that they would both be acceptable by the myZipWith struct, or rather this myZipWith function. But even if I could do this, it wouldn't work. Okay. Hey, how you doing? Patatas del Papa. I hope I haven't mispronounced that. I'm going to guess that has Spanish roots, and I don't speak Spanish. So I apologize for mispronouncing. But hi, how you doing? I'm a new Rust person, and I apologize for the thumping on my desk. I do that every once in a while when I get frustrated. I pound on my desk. I really got to stop doing that because somebody has already commented on it. So I can't do this. And I need to do this to make this generic across not just functions or function-like things, but actual full closures which can capture values. I do not know how to do this, and I have, I'll admit, looked into how the systems version of myzip is implemented, and I could just clone it, that I would learn nothing. So let's go back a second. Let's go and build this in its working operational form, if I can. I'm more frustrated on my internet. Don't worry. No worries. Okay, so now we're back up to building because we're back to what we had before. Okay. Yeah. So before I even get to implementing my merge zip, I need to figure out the best way to get around this problem, and if possible, don't use anything allocated on the heap where possible. So actually, I want to illustrate something, though. If I... don't know what I want to illustrate here. Let me think this through. I can't get the type of this up here. I can't state what the type of this thing is early because it could be capturing something. And the reason in the by the way, that this matters to the merge zip width is I wanted to make merge zip width itself depend on, sorry, I wanted to make my zip width, which just does a zip width function with an arbitrary function. I want to pass that function off to merge zip width, and that's what merge zip width is trying to capture. Which it can't for similar reasons. This is why I backed out one layer. It doesn't matter what I'm capturing. In this case, I'm capturing a lone item, a y, but what I really should be worrying about is the capturing effectively of the function f. And here I'm just stashing it into my zip width so it doesn't matter. Because it's actually formally passed in as a parameter. But in order for me to fob this off to merge zip width, I have to be able to state the 2-parameter version of f that I manufacture inside here. By the time I manufacture the function as a lambda, again, it's too late because, and I'll show you this actually, it's right... I will get there eventually. That's not it. It's actually down here. It is... That's my zip. Here it is, my zip width. This is where I try to fob off the responsibilities on merge zip width. In order to do that, I have to give it a new function described by a closure that that takes the original zip function, which zip width function, and applies it, wraps it up in a sum, and then just says to advance both lists, which is exactly how zip works. So I pass this function in to do the main work, and I say that if I run out of stuff in either list, I just halt everything and return a none to add to the stream. This is more or less how my C++ and in fact exactly how my C++, C#, and Haskell versions handle using merge zip width in order to implement my zip width. What I want to do is I need to pass this function off, but I need to modify it. Like I need to create a more powerful function out of this function that I'm passed in. And so I can't pass this directly into merge zip width. I need to pass in the altered version into merge zip width. And I can't provide that 2-parameter function as a trait for exactly the reasons that I'm currently fighting with my basic zip. So this is effectively the where I started encountering this problem. And so I looked back and I discovered that yes, my zip doesn't even work correctly either. Not on all types. Not on all functions wherein the function is actually a closure that does a capture. Precisely because of this guy. This is not any kind of function. This is only a pointer to a function that captures no values. It's the only thing that can be converted to a function pointer. So this is not complete. I have to back out a layer in order to solve this more generally. So damn. One of the things I can do though, in order to clean this up, is actually to make this look like the other functions where I move the y's down here. For the moment I'm going to do this, even if it's a bad idea. so that I use the same trait and implementation for any kind of y's. So let's just clean that up. Oh. Except that makes the R part of this not work. That's why I did it this way. Well, crap. Okay, you know what? Undo all that. I'm not going to change that right now because it's currently working. Seems interesting. Sadly, internet can't handle the stream. Good luck. Hopefully you don't get a limitation of the type system. I probably... Yeah, sorry you can't stick around, Patatas. I hoped I was actually streaming only 720p, but if you can't handle that, then I don't think I have a way to degrade it. But yeah, see you. I hope you find a stream of suitable funness that you can actually cope with stream-wise. See you later. Thanks for showing up. I do not know what to do this. I think this is not so much a limitation in the type system as such. It's a limitation of my ability to capture a later type and stuff. Well, that's a problem in the type system, right? If I could state the right type, I'd be fine. I need to be able to have the return value stated not here, but sort of afterward. So isn't that interesting? So one solution to this would be to make this return type auto, right? Or like this one, make this auto. The other would be to actually have, if you wanted to say it this way, have the have the return value stated after the code. Now that would be terrible to read. I wouldn't want to do that. But a third, so instead of using auto, you could do and just do return type deduction. You could have the return type appear afterward, right? Because then inside here you could introduce new types. But then if you could introduce new types inside here, then why not allow it so that the return, so that types that you introduce inside the function by way of some keyword, say export type, can be seen by it can be seen by the outside world. Now that is a little bit like return type deduction, except that it's explicit. So so as a syntax measure, what I would love to be able to see is something like this. So I need to know what the actual type of the one and only lambda is that I'm going to be using here. So what I could do is I could do something like this. I could pull this out of here, and I could call this, I could actually call this f. And then I could say, if I wanted something like, no, I need an actual value here, so I'm going to call it f. I could say let f equal this. So now it's just a function. It's a lambda, whatever. I could then say something like export type. I don't even know what this would be, but export type of f. So type, maybe type equals. Should I just call it export type? Export type f equals something like this, decal type f, to use a C++ism. And then I could use this up here. Now that would require me finding this and being able to export it out here, but then it's not so much return type deduction. It would just require a pass. I don't know what stages of compiler this would take, but I could actually, this is actually explicit. There's no deduction going on here. I could actually make this absolutely explicit. And then this would all just work, because then I could just replace all of this trait stuff with the actual type of the thing. There's still only one of these. Like, I'm not creating more than one value, and therefore I'm not creating more than one type. But this would enable me to solve the problem, and I don't have this luxury. So either auto return type deduction or something like this would make this a million times nicer, because I don't care that the thing that I'm returning doesn't have a specific type in my case. Maybe that's not a rusty way to think about this, but this does mean that I would have zero cost in using this thing, because anything this did get stored in would have to be itself be able to take an anonymous type. Okay. Yeah. I have no way to make this into a quantity deduced on an expression, which is sort of what I need. In order to solve it this way. I know this is not the way that zip is solved in. In fact, you know what? At this point, let's just go take a look at how zip is solved. Like I said, I have already... hang on, let me just make sure these window sizes are sensible. That's close to sensible. This is zip width. This is in fact the implementation of zip width, the very thing I'm fighting with. Well, actually it's zip that I'm fighting with, but and actually zip width itself isn't the problem. It's what would happen if I tried to. So this isn't actually going to tell me anything, because this is actually more or less how I implemented what I implemented. Their loop is a little bit different than mine, but and I should start looking up into things like the and thens. I have not done that. I mean, you can see how my zip width is actually implemented. And I could have done this with a match instead of an if, but basically I just test to make sure I have an element in each of them. And if I do, then, and I do that by doing next, because I know I'm always going to advance both, I just wrap it in a sum. So it's not quite the way they did it, but I think it's, you know, perfectly sensible. Otherwise, it looks, you know, an awful lot like theirs. I wrote this before I ever looked in this code. This one isn't the problem. The problem is zip. Because I would like zip to default to zip width. And I'm willing to bet that it isn't. I'm willing to bet that it does it directly in order to avoid this complicated little snarl. In fact, let's go take a look, shall we? So we're going to go to structs. That's not the one I want. I actually want ordinary zip. No, that's searched by. That's not exactly what I wanted. All right, let's just do this. Rust zip. There we go. Probably. There we go. And I'm willing to bet if I look at the source for zip, it does not use zip width to do its work. I could be wrong. Index linen 8 are only used by the specialized versions. That's fine. I would argue maybe a little wasteful of storage, but whatever. So that's the struct, and then we're doing an implementation of, that's just an implementation of new. Super nth I'm not interested in. Is it actually going to give me an implementation of iterator on this? trusted random access. Yeah, this is going to be way more sophisticated than the stuff I'm doing. And I got no beef with that. This is a general zip impl implementation. So this just does zip, and then it does... the default next is just to return sum. So it's doing it directly. Which is a perfectly sensible thing to do, incidentally. I just didn't have to do it in any of my other languages. So what is merge in merge zip? What is... sorry, I'm new here. Oh, hi. Yes, so I'm afraid I don't know how to... Oh, sorry, hang on. Nel2. Okay, good. I think I've got your name. I hope that's correct. Yeah, so to recap very briefly, the thing that I'm doing is the when I was doing a puzzle for the Advent 2020, actually the very first one, the way I chose to solve it involved walking down two lists at different rates and based on pairs of values emitting a result if I thought it was useful to emit a result. And the merge part of merge sort just walks down two lists that are sorted and chooses one or the other and emits it as a result at that point, and then continues to walk down the lists at different rates, producing values. And those seem to me to be very close cousin operations. I wanted to write a higher order abstraction. I wanted to write something that at a higher order would allow me to solve both problems using the rules for advancing the lists coupled with the value that was the combined output. And in the I can quickly show you that in the I don't mind going back and checking this out again. I go back and show you the Haskell version of this because it states it pretty succinctly, except I have to go to OBS and turn on that window. Doink. So there we go. So to illustrate the point, basically, here's the entire function I'm attempting to write in Rust, which is proving to be annoying, as well as my own version of zip and zip width, which are the standard zip and zip width you might find in lots of other languages. My zip being basically to zip up two lists as into one list of a tuple of the elements of each pairwise tupling of each of the elements of the lists, and zip width being more generic, which is to take a function to do the combining, so that you can do it for, you can use zip width to implement it that way. Sorry, you can implement zip width that way. You can also implement a dot product that way with the help of a fold to add everything together at the end. And you can see here that the merge operation of merge sort and the idea of finding two elements of a list that sum to a particular third product, which was the thing that I pulled out of the Advent puzzle, can both be implemented in terms of this merge zip width. So that's the ultimate sort of starting point to where this little puzzle came to me. I decided that the operations I was doing to solve this problem for the Advent 2020 first puzzle was essentially the same operation as what is needed to do the merge part of merge sort. There's the merge. I don't have to do anything else. Now, I mean, I could have written a merge manually. You know, can do it live even. Merge 2 would basically take in, let's see, if we had an empty list, if we had two empty lists, then we would just return an empty list, doing this in Haskell. Merge 2, if we did not have an empty list in this, but we had an empty list in that one, then we would just return the tail end of the list. These being sorted, because in merge sort, the lists you supply are already sorted. And for the opposite case, where only the right-hand side exists, we just output that, because that's all that's left. And then where we have some from both, but we know that they're not empty, then I'm going to extract an element off the head plus everything that's left, and an element off the head of this one plus whatever's left. And then I would basically do the equivalent of, actually, so I could do a guard here, doing this all live for you. So if x is less than y, then I think it's an equal sign for a guard. Then output x, and if In every other case, sorry, I have to do x plus the result of processing the rest of these lists. So this would be the remainder x's and the remainder y's. The same thing would be for, actually in every other case, I could just say basically otherwise, which is essentially the same thing as true. It's just always true. The catch-all case is to do. Actually, I can't quite do that. We'll do this because I need to be able to capture the original x's and y's if I happen to need it. So in this case, I'm popping one off of the x's, so I'll use the tail version. In this case, I'm popping one off the actually, in this case, I'm popping one off the y's. Actually, in either case, I can pop one off the y's. Because if they happen to be equal, then I want to process one list and then possibly the other on the next pass. And I think it's very close to a working merge operation in Haskell. So, and this would be something similar that you could do in a loop. In fact, the loop for my existing Rust version looks a lot like this. Popping very quickly back over, in fact, let's just go take a look, because I will show you that my prospective hopeful code, my hopeful code for this in Rust is actually up here, commented out until I can get some type stuff sorted out. Is very much the same. Instead of recursion, because Rust does not have tail recursion elimination yet, I had to do this in a loop, but that's fine. So in the loop, basically what I'm saying is, well, actually, hang on. This is the wrong way to look at this, because this isn't merge. This is my merge zip. But it kind of follows the same format. I'm basically saying, take a look at each items, and there's the both lists are gave me no information, no data available, nothing in the list. That's my nothing in the list case. This one's my left hand has something. This one's my right hand has something. This is my both lists have something. And the only real difference here is instead of just outputting an element based on greater or less than, I actually call a function to get me information on two things. One of which is, what do I adjust in the lists, either both left or right, or to halt everything, which is the last one, the catch-all case, just stop. And I also at the same time output a result. So this is basically the motivation behind this implementation. And this compiles, except it makes some assumptions on being able to populate this structure, which comes down to all my type problems at the moment. So I decided to stop working on this until I can solve my type problems on the simpler case, which is implementing my own zip and zip with. There we go. We're reiterated where I am in this operation. So the basic problem here is that so I've got zip and my zip both written. I could write my zip so that it universally behaved itself, because all I would have to do in my zip is just essentially return for each step of. It's the best way for me to put this. All I have to do is implement my own structure containing the state information custom to my zip, which I've done actually. Where is the version of that actually does that? That is here. No, it's my zip withable. That's the zip with version. I've got so many commented out versions I don't even know where I'm looking anymore. Here, actually. This here works as a universal myzip primarily because it doesn't need to know some sort of abstract function to call. It just wraps them in a tuple. That's exactly what this does here. This works just fine. It should work on any lists. That should be fine. But the problem is then, okay, so then I went to write zip with, and I believe that this too will work pretty universally, because as long as I can populate this with a value which is of a type whose trait matches the ability to be looked at as this function signature, because all function types, all closures implement something, one of the variants of fn, either fn or fn mute, or I think there's one other. As long as it lives up to this this operation, or at least as long as a passed in function, or the thing I'm asking to build this with, adheres to this, should be able to shove it in this struct. It shouldn't matter as long as I can populate this. I believe that zip with works, and in fact I verified that it does work by basing zip off of it, and this comes straight from the Haskell version, and actually the C++ and C# versions, where I base my zip on my zip with, because the only thing I have to do is say zip with and pass in something that says build a tuple out of it. This is effectively the with part. Please zip this with this function. The only reason this works though is because this is effectively a function pointer. The minute I make this, the minute I try to do something that requires capturing of state, it's actually good for me to go back over this, because then I make sure I am not confusing myself. There we go. So the problem with this is here I am passing in the y's into my function. So hang on, I need to undo something that I was doing before. Let's get this back to working order, or properly non-working order, because there's no such thing as export type and decal type in. All right, there we go. We're back to normal. We're passing in y's, but we're ignoring it because each of the elements gets processed through this function, through this closure as q, but then I'm ignoring q. What I'm actually stuffing in the tuple is a compatible type, which is a common type y. So this is like zipping with a common y everywhere. And so what this essentially ends up being, this should work, and it doesn't. And the reason why is because this is not a type that is compatible with pointers, function pointers. If I made this fn, I still get errors, because it captures something. It captures the common y. This does not come in the parameters. It comes in from the outside. Perfectly thing to do in a closure. However, that takes it out of the categories of things that can be represented by this function type, and I'm saying that I'm returning this structure with one of the types having to be this function pointer type. So down the road, this doesn't match, because every closure effectively that captures anything has a unique type that can never be represented by just a function pointer. Just a pain in the neck. Yeah, I try to build this. The problem is mismatch types expected a function pointer but found a closure. I cannot convert this to a form that is compatible with this. I mean, it's a longer type. Hang on a second. It's basically a function that takes two items and returns some result. The minute I make this a trait, I now have a trait in place of a type, which means that it expects it to be basically a trait object, which can't be stuffed in a structure when it's not a concrete type. This is not a concrete type anymore. I can't make it an f, just an arbitrary f, because I have no way to auto-deduce that from anything that I have available to me. The actual proper type of it is the type of this thing, but by the time we get here, it's too late. I have to have the return value already stated. So I think I've walked through that twice now, and it hasn't changed in my head. That's still the problem I'm left with. Is in order to do this for arbitrary functions and not just things that can be turned into function pointers, I have to do something that involves getting a piece of type information up here that I do not have. I don't know of any clever type wizardry that enables me to get around this. In Rust. C++, I have auto. In Haskell, it does deeper analysis on the functions, I think, in order to unify all of the types. It doesn't just look at the signatures. What I really want, arguably, is I want Rust's type. I want Haskell's type system, but with Rust's borrowing and memory management mechanics. I think that would be a cool hybrid. Don't know if it's even possible, but it would be interesting. Right. Where do I go from? Oops, sorry. Where do I go from here? Yeah, they call it zip. They call this thing. So, what is zip impl, and what does it store that zip does not? I'm kind of curious as to how they did this, because maybe there's a technique in here I can learn. I mean, it's all stuff I can learn. Ah, there we go. Zip impl is their trait, and that's the trick that I'm currently using. You can clearly see that. I called it my zippable. They called it zip impl, zip implementation, which is not really an implementation, it's a trait, except that allows it to implement so that's the trait, that's the implementation for zip, including the function they called it function new, but they did not, they laid this out a little bit differently than I did. Oh, they put the new in here, they put the next in here. I see. They put a number of useful functions in here because why not? More or less like what I did. But you can see that their next operation is literally just, in the case of the zip, they did not fob off the problem on from my zip up to my zip width. That's what I'm trying to do. I'm trying to reuse my zip width so that any logic that I create is buried in that. They do not have the problem because they don't have a function to pass off, and I do. They don't have a closure to pass off, and I do. Which may mean I'm doing this quote the wrong way, right? But I want to see if there's a way around this. I already know one way around this. Make this a type that is effectively on the heap in some sense, or dynamic in some sense. Still frustrating, though. Yeah, so they're coming up with a bunch of implementations for this that are all actually overrides at the type level for different kinds of iterators. Because this one is for the double-ended iterator. This one's for trusted random access iterator. So they've got a bunch of custom implementations for efficiency reasons. I find it interesting that they decided to overload their type system, but they don't allow overloading of the function calls. There's nothing wrong with that. I actually like the fact that Haskell doesn't that Haskell does not have the same thing. They don't allow overloading of functions. I actually find that useful. You can do some neat type wizardry stuff, don't get me wrong, with overloaded functions in C++, but I'm sure it comes at a horrible cost. I know it comes at a horrible cost. Finding the function that's actually getting called is sometimes problematic. Okay. I don't think this is going to help me. Yeah. So there's a couple of ways I can think about doing this going forward if I can't find a workaround to this type thing. Because I can't do return type deduction. I can't return an impl of something out of a trait. It's a weird restriction. There were some technical reasons in one of those RFCs I read, and I understood about half of it. I can do a couple of things. First of all, if I insist that I'm kind of trying to insist that I fob this problem off on my zipwith, because I know I can solve this the way they did in Rust, which is just to write it independently. But I want to daisy chain these functions. Code reuse, to me, is a great thing. And really what I should be able to do is literally this call. I should be able to fob off the problem. In order to make this work, though, I got a couple of choices. I can either try to build a zipwith structure, the actual iterator, effectively, with functions that are referred to dynamically by way of being boxed on the heap. That's probably the only way I can do this, because this iterator is going to live past the point of the end of this function. I can't return a reference to a local object. That's a no-no. Like, I can't borrow from a local, because the local is going to go away. It's no better than passing back a pointer to a local object in C++. That's just a no-no. So I would have to put it on the heap, and that means the allocation, actually, and destruction of that is going to take time, which I don't like. That's why I want to keep this thing static. It's basically what they referred to in that RFC as an unboxed closure. Or, so I either put it on the heap, or actually put the functions on the heap. Or what I do is I actually have instead of fobbing this off on a my zipwith structure, I fob it off on a my zip structure, like recreate my own iterator structure that contains within it other iterators. In order for that might work at the cost of storage, maybe. Because what I could do there okay, so if I did that, what I would have to do is I would have to create that's a different problem, because what I would have to do is I would have to create iterators that I knew were generic. No, what I would have to do is I would have to create a I have to create a zipwith iterator. That was given the right type, and then hide that would create, so passing in an unknown function would make the zipwith structure itself an unknown type. The function an unknown type bearing a structure would have to make that structure an unknown type, because it's made generic off of, it's reified on a compiler provided type. That would be my iterator, but in order to return it, I would have to return it under the guise of like an impl. it would have to be an impl trait return thing again, or I box it. And I can't do that in a function that's part of an implementation. Keep running up against that same problem. I can't do an impl trait return type out of a trait for restricted reasons. I could do it if it were we're just implementing a method on a structure, but that's not what I'm doing here. I'm sitting here talking to, well, all of you, while I am sitting here and beating myself up over trying to do something that may not be possible. I either build the... I'm not actually building the myZipWith structure here. I'm just saying that I'm returning one of a particular type. Fortunately, I don't know what that type is until here, like I said. All right, so here's the thing. Let's temporarily the question is, if I knew what this type was, could I make one of these at all? Like, if I had the knowledge of this type early enough, could I make a myZipWith at all? Am I allowed to make a structure of that type? Let's actually test that, shall we? So here's what we're going to do, because this is a question. The question is, can a structure of unknown type, can a value of a compiler, I'm not going to say unknown type, that's the wrong way. I've been saying that for this entire stream. What I really mean is it's not knowable by me. It is not that the compiler doesn't know it, it's just that it's unique to the compiler, and I never get to see it, and I can't type it in. That's what I meant, have been meaning by unknown type. It's actually known only by the compiler. So I'm going to say compiler-generated type. Maybe compiler-generated unique type, CGUT? I'm going to call it a CGUT. No, that's terrible. That's a terrible acronym. Why didn't somebody stop me? Okay, so let's say let f equal this. Right. So first of all, this is a value, right? This is a value f. It is bound to. I try not to say assigned. It is bound because it's not mutable. I'm not going to say assigned. It is bound to this value, which is a closure, which captures a value, right? Which captures a local value, the y value over here. Just like before, there's nothing magical going on here. If I were to say something like, okay, hang on. Just to get this to compile, because this is not the thing that I'm testing, we're going to say x, y, and we're going to return x, y. So this just compiles like before. And I'm just going to make this one of these again so that everything builds and everybody's happy. So that's not the problem. I'm not interested in this for the moment. So give me a moment. Here's what I'm going to do. So this is saying, consider giving this closure parameter a type. I kind of don't want to. Am I required to? Because it can't deduce the type from context. Because I'm not passing that closure to something. Gotcha. So, okay, so x we're just going to say is, it doesn't really matter actually, because I'm not going to give this to anybody. An I32, and this is going to be an, what is that, an F64, doesn't really matter. Whatever, sorry, and this is going to be x and y. And I think that's okay. What's it whining about here? Mismatched types. Why is this a mismatched type? Unused variables. Oh, yes, I don't care about unused variables. These are all going to be unused. So we're going to have that. don't know why it's saying mismatch types here, but let's grind this. Okay, no, it was a false error. It didn't analyze it properly completely, so a full build got rid of the error. So this is just an ordinary F. I'm ignoring it. But the question is, can I even create this if I know the appropriate type? No. And the reason why not is, oh, God, sorry if I keep pounding on the table. The reason why is because I can't actually say type of this lambda. I can't do it. Here's a thought. Ugh. Always with the spammers coming into the chat room. Thanks for nothing. All right, so here's what we're going to do. I can get the type of F if I pass it into a function. I won't be able to export that type out. Actually, I want to make sure this is actually the same as the one I'm trying to. No, hang on. Colon Q equals. Yeah, that's what I actually want to say. I want to make sure this is a version that actually captures a value. What happens if I do this? If I do fn foo, which captures a type T, and then I'm going to go I'm going to capture type F. Can I even do that? Am I using F anywhere else? I don't think I'm using F anywhere else. So if I say function first, and then I go F is an F, where F is this function type I'm trying to deal with. See if that builds. Does not, because I don't know what I'm doing. Can't use generic parameters from an outer function. Did I have an F in the outer function? Oh, yes, I did. So I can actually just, rebuild these. I can basically say X's, Y's. No, this is not what I'm after. I'm not actually reproducing the F's. This is going to be the entire. I need to figure out what F's type is captured as an actual. This is not what I'm intending to do. I don't want to make this fully generic yet. I'm just going to confuse myself. So this is going to be an I32. This is going to be X's, which is going to be, the function is going to be X, which is going to be an I32. Y, which is going to be, Q, which is going to be an F64. And that is going to produce an I32 in a tuple and an F64. Is this even sensible? Have I done anything sensible here? I don't need this. This is not how I specify the trait part of this. It's not liking that because can't use generic parameters from outer function, but I'm not. I32 is not a generic parameter. I'm going to rebuild because I think it's gotten confused. Yes, it got confused over that. And this is function is never used, which is fine. That's exactly what I want. So if I now do foo underscore f, it says so let, actually this doesn't return anything. No, this should return nothing. This is just calling a function, just calling an inner function. I'm not actually returning something out of here, so it's actually acting like a statement. Type mismatch involving closure. Why is it FN once? Because it's not taking it by reference. I gotta look up FN once now, because I don't remember. Instead of FN, whoops, you can't see that. Let me try that. There we go. Rust FN once. So FN once are functions that can be called once. FN represents self. Oh, that's when it's so the traits each represent more and more restrictive properties about closures functions, indicating by the signatures of their call method, particularly the type of self. A closure will automatically implement as many of these as it can. All closures implement FN once. A closure that can't be called once doesn't deserve the name. Note that if a closure only implements FN once, it can only be called once. Closures that don't move out of their captures implement FN mute, allowing them to be called more than once if there's an unaliased access to a function object. Closures that don't need unique or mutable access to their captures implement FN, allowing them to be essentially called everywhere. The reason why this is FN once is because it actually captures Y permanently into itself. Because this isn't F64. I'm actually capturing YS : item in here. Darn it! Darn it to heck. Alright, so here we go. Let Z equal 1241. And it's actually going to be, Z is actually going to be an F64. See, the problem is I'm actually capturing. There we go. So let's start there. It's still not going to work, but unused variable Y. That's true. It is unused. Unused variable F. That is true. I haven't used it yet. And that's it. So, because I'm not currently using that Y, let us, on purpose, put an underscore in front of it, which I think should tell it to stop worrying about that. Yeah, now it's only complaining about F. Okay. Yeah, you got there ahead of me. You got there ahead of me. Sorry about that. I should have read your stuff before I got to it, but thank you for helping and keep doing that, because sometimes I will look at the stream before I actually look at my code. I'm not yet used to reading the Rust, the Rust errors. It's going to take me some time. Although I do have to admit they are generally far better than the corresponding C++ versions because of all the duck typing. Errors get buried way, way deep. Okay, so I'm not using F at the moment. And actually, I don't necessarily care to. Actually, what I'm going to do in here, though, is I'm going to say let M equals this guy. And I'm going to see if I can actually construct one of these if one of the generic parameters is one of these unknowable types, because then I will know something interesting. It means that you can store them as long as you know what the type is ahead of time. And I do know what the type is ahead of time in this case because I have passed it into a function where it, sorry, I keep tapping on the desk. I should wrap my fingers in winter mittens. I actually captured the type inside this function. Now, this doesn't do me any good for this function as a whole, but this should tell me something interesting. So what I should be able to do is this is no longer... I'm going to need R passed in here as well. That's going to be a problem. No, it is not, because I know what the return type is. It is, in fact, identically this. And actually, you know what? I could actually return it to its former glory by... You know what? I'm not going to do that. Nope, I'm getting out of hand here. I'm going to say that I'm going to let that occur for the sake of type checking. We're going to build. Still doesn't like it because it expected a semicolon somewhere. I'm doing something dumb. I need to do a myzip with it. It says I'm not allowed to use self because... Oh, Lord. Okay. This probably won't work. Pretty sure this won't work. Self parameter is only allowed in associated functions. Not semantically valid as a function parameter. Great. Okay, so that's fine. What I will do is I will use self as a parameter here. Because this is not an associated function. I believe associated function means associated effectively with the outer type that I'm implementing, but that means that this has to be S. This has to be S. I'm going to call it S, which is going to be capital S. I still haven't got a full handle on where this self and this self can be used in every case, but I'm just trying to see if I can make one of these at all with a type that I don't know, but that I know is unique, but that I don't know personally. And if that's true, then I can do myzip with that, except I need the Y's as well. God, this is just getting more and more complicated. All right, so we're going to do the Y's passed in. So I'm going to do S. I'm going to do I'm not even going to call it Y's. I'm going to call it T. So I don't really care about it so much. S and T, and in fact, none of those are going to be used either in this function, so I'm going to ignore all of that. So that's going to be S, that's going to be T. I'm going to do a self and Y's and F. That's T, that's T. This is complaining because, I don't know, let's give it a full compile and see if it's still whining. It still is. Why do we have a problem? Because because I'm not sure. I do not know why it doesn't like S. Of S, T, and F, with the parameters S, T, and F, F is actually not being used, so I can do that. but that doesn't explain. All right. Let's go and build this again. It's because I'm not actually constructing an object with this? No, that can't be the case. Because I don't, you might want to give Rust Analyzer a try. You know, probably. Although I think the issue here is that I don't specify construction of this in this fashion. What I actually do is like what I do here, where the types are determined by my initialization of it. I simply don't manually specify these. Oops. Where did my function go? Where am I altering that? That's fine. So what I really need to do is not this, because this can be deduced from my filling in of the actual parameters. So in this case, x's is bound to, yeah, it's missing a bunch of stuff. X's is bound to underscore, is bound to s. It's no longer an underscore. I don't need to worry about this. I'm actually going to have to pass all of these in. This is doing nothing to solve my real problem except give me some insight into the type system. I want to be completely clear. I know that that's the case. Y's is going to be T and F is just F. Okay. S is not an iterator. That's because I did not constrain S to be an iterator. So I can do that here. No, I can't do that here. I have to do that here and here. Let's do a full build and see what it winds about. Expected a should be a lot of fun to figure this out. It may have outthought me here. Oh, that'd be great. I like when a compiler outthinks me. I mean, it means I have to fight against it more, but we'll save you the rebuilding that you have to sometimes do. It won't solve compiler errors, it will save you the rebuilding. Yes, I will look into doing that offline. I'll definitely look into adding that as a plugin. Saying F should have S item and T item. That's interesting. Oh, because I'm an idiot and I have provided iterators to things that are of the abstract type X's and Y's. Hi. Yeah. How do I do an array again? do some fixed size arrays. So fixed sized arrays. I think all arrays are fixed size. Let x's blah 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 of a particular type equal. Oh, and this is a way of initializing by way of a. Okay, so I might actually need. So if I did something like this, and I call it tease. And use. This is going to be F64s. And it's going to be 1.0, 2.0, 3.0. Sure. Am I just going to make this work worse? It is not an iterator. That's true. It is not. Quite true. Down to 3, expected. I am just making this worse. Because this is not a, no, this should be, back to check out the myzip with structure just to figure if I can remember. So I need myzip with x's, f's, y's, the function, and r. The function should take x's item and y's item. What does the error say? S as iterator item, T as iterator item, closure, found F. But F is one of the generic types. I'm only constraining it to be of the particular functional type that I'm outputting. S is iterator, colon, colon, item. T is iterator, colon, colon, item. So what have I done here? I have said, that right, because that's why this bounds isn't working. That makes sense. That makes sense because I can't guarantee for any passed-in parameters. So I got to reason this out. I can't guarantee for any passed-in parameters that that the constraints I'm asking F to obey in my zip width as part of this constraint is necessarily going to be related to the iterators. That is, I could pass this set of constraints here, the iterator constraints for S and T, and the function for F, and the iterators, the types of S : item and the type of T : item are not at this level, at this definitional level here, guaranteed to be I-32 and I-64. Yeah, so this, okay, I gotta remind myself. So yeah, I'm working it out. Yeah, no, I totally agree with you. I totally agree with you that that's what I have to do. I'm just trying to reason out why it's an issue. And the issue is, like in C++, I believe this would have been done in 2 passes, so that it would not actually, I don't have the where clause in quite the same way, so that's not true. Never mind. And that only comes in C++ 20 concepts anyway, so... man, I'm getting old. Right, so S : item, T : item, and then the same thing effectively occurs here. So now, where did my code go? So now, sorry, I lost my code. Where did my code go? Right here. It finally did the code formatting thing on me, which is it has not been doing it absolutely forever. Very frustrating. Okay, let's try that. Type mismatch and closure arguments. This is exciting. Or you can constrain S iterator item equals I-32. I totally could do that. Good point. I'm not used to that, and I still haven't figured out a good way to force into my head the idea of stating from the outside an associated type, stating from inside an associated type, and having that type not associated but in the generic parameter list. I still have to get all of those cases sorted out in my head, but I understand what you're talking about. But let's find out what this new font of evil is. So that's no longer an unknown parameter, so let's just make sure that's not even a thing. So hang on. Foo iter, and then it says underscore F. Well, we're not doing that. We're actually making it a proper. Let's first of all get rid of the underscores because that's no longer true. Array iter is an iterator over ampersand t. Expected signature of ampersand I32 and ampersand F64. Because of course. Okay. That's extremely because they can't be moved out. I am slowly getting there. Because they can't be moved out. They can be copied. But I have been operating on, down in here, I've been operating on vectors instead of... Vec has an into iter method. Yes, it does. Okay. And actually, that's an interesting point, though, because in a lot of my other work on zips, I have been using iter and not into iter, because I think the zips, my standard zip width, the functions I've been giving it. Where's my original zip? That's an interesting question, actually. For my original zip, which actually works, I was passing off vex iter method, the result of vex iter method. If vex iter method returns, if it expects a function of references, if I'm pulling out references here, and this, your zip would yield, yeah, I think you're right. That's where I was going with that. So I was sort of ignoring that issue, right? So what that means is I'm borrowing it, but I'm not mutating it. Okay, so I can have as many borrowed references as I want. So you're right. I think you're right. I think I was having a sum of a tuple, like I was ultimately returning a tuple of references, but because the original backing thing was in the same code block, that was okay. Yeah, okay. Yeah, it inferred the types. But the critical thing is it wasn't a mutating reference. I was just collecting them up in a tuple. And then when I was outputting them, I presume it was just ignoring the fact that it was a reference. And like I wasn't paying attention to it. Like outputting, I guess, the toString of a reference type is just its a toString of its underlying type, or whatever. It's not a toString, but you know what I mean. The stringizing operation implicit by inline. So when it was doing this debug printout, it was ignoring the fact that what I probably have here is actually a vector of tuples of references, and I was just completely ignoring that because I was using okay, no, I'm totally okay with that. I understand that. That's fascinating. I find that fascinating. Okay. What I want to do is I want to say, I think it's vecbang of, hang on, how did I do it down here? I just said vecbang and then a couple of lists, right, of values. So, good God. All right. And its type is inferable. I'm going to just say vec underscore because I don't actually care what it is. Please infer it for me. I do like that they've taken some pain out of this. They just need to do more type deduction than they're currently doing for me. Vecbang, and then instead of iter, I want to do 2 iter. Let's just stay strictly speaking on values, so I'm just not monkeying with that. You can just do let x equals. Yes, I can. I don't need to actually specify the types, do I? And in fact, I forgot the equal sign anyway, so. Yep, okay, I'm totally okay with that. I'm totally okay with that. All right. Slowly getting there. Type mismatch and closure arguments. No, it's not the. I want the debug. No, it's not the debug console. I want. Come on, just build. Build and show me the problems. Problems don't. It's not found in vec of integer in the current scope. Oh, okay. I thought that's why we were going with vectors. So, Rust vector to iter, or into iter. It's into iter. See, I will get there. I will get there. I didn't do it on that one anyway, so let's fix that. Holy crap! Holy crap, it type checked! Okay, this makes me grin like a Mad Hatter. Not because of all this junk, because, I mean, I had to learn that anyway, so that's good knowledge. But also I have to remind myself that when it's compiling this, it's not using duck typing. I actually have to sort this out based on types knowable at the functions. I have to sort this out as types knowable at this point, and if I have an unrestricted iterator. I can deduce, I find this really fascinating as a type mechanism, actually, because iterator has an implicit type that's not being specified, and that's its item, and so does T. Like, this is not a concrete type at the point at which I'm saying this. Is actually effectively some arbitrary type that has a trait, but that trait is parameterized on something I'm not even specifying up here, but I am specifying it by way of this. So I'm actually effectively unifying a piece of this iterator trait based on this generic as being constrained to this entire functional this functional trait. That's some pretty funky type unification as far as as far as that goes. So I'm going to have to remember that I can do that sort of thing. That I can actually bind the interior pieces, the associated types of traits, based on external properties, and that's more or less identical to the as a short form. As you were saying, to put some sort of item equals thing in here, but in this case, it's being bound by its usage, the item's usage in that function trait signature. That's fantastic. I do like that. There's some things I'm fighting with here, but that I find really funky. But I do have to remember that Rust does not do duck typing, so everything, it's a lot like Haskell in that way. Everything has to be up front. Okay, and this has taught me a second thing, actually, and that is this type checked. So the idea that you can't store unique types inside a structure is just flat wrong. Like compiler-generated values of compiler-generated types can be stored inside of structures from a type point of view. The constraint about size isn't true because I've made it. It is in fact a concrete type. It's just not one I can type out. So if I can get in a situation where I know the type externally, like I've done here, because I can then take that f and I could apply it in a place like this, because at this point it's just a value, right? This is creating a value and creating the underlying type at the same time. But I could, if it worked, I could do this. If this were to match the type that I said it was going to return, this would all work out just fine. But I can't do that. This is how I would do it if I could do decal type f. If I could literally do this. Or its equivalent, type of, or whatever. I need a type of. And I don't think Rust has one. And I do know what the type is in here, but that doesn't help me because I can't let that knowledge escape here to the outside world in any meaningful way. In fact, it still doesn't matter because what I really need to know is I need to know that type at the level that's out here, which means in order to do what I want to do, I either need return type deduction or I need some sort of way to export f's type from this level back out to the type signature level manually, like I was experimenting with as syntactic blatherings earlier. All right, I have learned loads, and I am not going to be able to solve my problem this way unless I can get around that issue. I can't do an impl trait. Can I get around that restriction of an impl trait not being able to be used inside of a trait implementation? Is there any sort of workaround to that? It's still not ideal, but it would be a thing. This is din impl and trait objects. Which I'll have to look at in more detail as I start to get more into that part of it. This, by the way, was a great little post, why Rust closures are somewhat hard. I actually quite liked reading on this because it made very clear. This is kind of made clear when you talk about C++ lambdas as well, because they just devolve effectively into a class object that has method parameters. That's all this has done. This is totally reasonable to me. This surprised me exactly none at all. You can try trait objects. Yes, there are trait yes, you are correct. There are ways that I can get around this that involve some kind of dynamic allocation to get around this, so that it's and dynamic dispatch. The problem with that is that I really only want what's the best way for me to put this? I really only want an unboxed closure to sit in my structure. The reason being is that I don't have to do a dynamic allocation and I don't have to do dynamic dispatch to call it. Now, that may be overkill because effectively to completely, well, see, in C++, I can do that. I can embed, just like I did here, I can actually do this right here in C++, except that because of auto return type deduction, I can actually export this outside the function. I just turn this into an auto at the end. And the implication of that is that I can embed an arbitrary lambda or an arbitrary function as a member variable of that structure, like I'm doing here, at the cost that effectively the entire structure becomes compiler determined because one of its members is, which is kind of what I'm doing here. And I would be willing to take that hit just to play with the type system. In C++, in order to, what I can do is I can use the std function wrapper that effectively information hides whether or not the underlying thing is a pointer or a lambda or whatever, so that I can just call it a function object, so that I can still stuff it in a structure, but then I don't poison the outer structure as being compiler type driven. Like it effectively erases that underlying type. And I think it actually may have to do a dynamic allocation to do that, but it may hide it in some other clever way. It doesn't really matter. There's some type erasure going on there that basically makes it you don't poison the outer structure with itself being compiler dependent, compiler generated. And that's cool. Both of those mechanisms would allow me doing what I'm doing. Rust is only allowing effectively the second, because the equivalent to std function wrapper around a function thing in C++ is some sort of type trait. That std function is, for all intents and purposes, the same as a trait object. So the cost is likely to be extra runtime cost in calling this function, and because it's being called a lot, that would be kind of a shame if I had to resort to that. I may have to, and that's fine. Yeah. I'm trying to find a way around that, though. And I don't think I can, but I'm still trying. At least I'm trying to see what my options are. What is it? Okay, so first question is, can I stuff an unboxed closure into a structure and return that structure? Maybe with impl_trait, because impl_trait is not, as a return type, I don't think it's actually allocated on the heap. I think it's a concrete type, but with restrictions. But impl_trait can't be returned from a trait method, and that's a restriction that makes it not useful in this case. Which is beyond annoying. Yeah, so here they're talking about using impl_trait as a parameter. Lots of information in the type. Yeah, so here we go. If we wanted to store closures, we have to box them. That's the conclusion here. Now, this is maybe a little bit old. I don't know how absolutely brand new this is. This may not be universally true anymore. I'm not sure. If we want to store closures, we have to box them. When we can store any functions matching fn f64 to f64 as box. So it's boxed up. A box closure is also callable, but it has known fixed size because it is a pointer to the closure struct. So you can put these boxes into a vector or a map, which is fine. It is equivalent to the standard function type. There we go. In C++, which also involves calling a virtual method. Box of blah, blah, blah is a Rust trait object. So, yeah, so they both involve calling a virtual method. So that's the reason why. So there's two problems there. Boxing it up almost certainly involves throwing it on the heap, because that's Rust's smart pointer method. Which I don't want to do because of the allocation and because of the virtual method. Neither of which I strictly need when I only need one of them. I don't need to stuff them generically into a structure for later. At least I don't need to stuff it into a structure and worry about the poisoning of the structure. I'm so close. I'm so close. I can do this. I can build a structure that contains a closure object. But I need to know what its true type is at the point at which I'm actually stating what my return value is. Because I'm sure actually what I could do, I could actually do this, I think. Totally failing. I just want to do one more thing here then. My zip width is going to return a my zip width that is templated on S, T, F, and R. And I have to have an R here. So I would say something like where R is this guy. And I can just do that. And I'm willing to bet that if I then do a return M and I take out this underscore, it is going to whine at me because I've gotten something wrong. Oh, too funny. Swing and a miss. Well, crap. Because we don't have this. We don't have that. Nope, that did not solve my problem, although I'm sure that was also a problem. Found comma. Expected. One of open bracket, close bracket, colon, colon, or open bracket, found comma. Well, yes, because why are you being a pig to me today? Why are you being a pig to me today? What is the terminal's output on this? Nothing more advantageous. S is an iterator, T is an iterator, F's restraint is done by outside, and so is R. Okay, I'll bite. What the heck is going on here? Well, I'm going to have to call it pretty soon here. I'm pretty sure it doesn't seem to be having much of a complaint with much of the rest of this, but I'm pretty sure that I should be able to return this structure out of here. And then just ignore it. I mean, I'm just going to ignore it here. I'm not going to ignore the return value because I can't do anything with it. Yeah, I don't get it why that type isn't congealing. Well, I do know why this isn't compiling, because this has to be not this. So this is going to be the same as this for a moment, just to get that to compile. Okay. Well, it is now 9 o'clock. I should start thinking about winding this down so I don't spend the entire evening just sort of stressing out over it. I'm pretty sure that if I can figure out why this isn't compiling, somehow I should be able to get to the point where I can actually return from this inner function an actual constructed object, just like my outer function is supposed to be doing but can't. And the reason being is that I am giving a label to the type by way of passing it into a function. I just can't pass it out of a function. Impl trait would allow me to get around that if this were in a function that were not part of a trait, and I wish they would relax that restriction, because I could then at least do that. I wish they'd do formal return type, like complete return type deduction eventually, so that I can just say, you know what, whatever this thing returns, that's what its type is, because then I would be able to return the outer type without consequence. Or export a type derived internally to the function to the outside world. But that is where I'm going to have to leave it, I think, for the evening, for my evening. It's been a lot of fun trying to figure this out, or at least trying to tease out where the limits are. I've proven a couple of things. I've learned a couple of some really great things about the binding of interior, like associated types of traits external to that trait. This is a neat trick. And I've also learned that I have to make sure that my function signature only deals with types that I can see. I can't assume anybody's particular usage of it and just get it to compile. And in C++, my little trick with putting the actual types of this inside of my description of the functions should have worked and did not, because it will actually totally deduce. Hey, Code Chick. Yep, just for a moment. I'm just about wrapping up. I would be able to deduce. In C++, I would have been able to unify all of these types with the that were the values were actually called with hard-coded types that were inside of this thing. And there were a couple of ways around that, but this was the best way to do it. And I think it shows that I can build that compiler knowable structure. I just can't get it out of here. Because of that, I'm going to have to look at probably doing this another way. I'm going to be spending the next few days until like over the weekend probably trying to figure out if I can get a way around this without having to resort to a boxed trait boxed trait object or some other mechanism for doing this that involves dynamic dispatch. Don't think I'm going to be able to do it. Very frustrating. I will be looking up how the standard library does some of this stuff to see if there's things that I can glean from that. But in any case, I am going to wrap this up for the evening. So I don't necessarily do this on any particular weeknight because it just happens to be when I get sick of actual work and want to work on something a little bit more in my headspace. Or at least just a change of pace in my headspace, I guess. I occasionally do this on the weekends. Most of the time I'm doing game streams, actually. But I've decided in the next, at least over the next couple of weeks, probably a little longer, to keep sharing my learnings about Rust with you. And all of its foibles and all of my misunderstandings. So, thank you very much for all of you showing up. Feel free to add me to your list or just stop by whenever you see me online. I love to share stuff with all of you. I've learned a couple of great things from you. In this particular case, Gray Jack and especially Null2 this stream have been absolutely fabulous in providing some hints for what to look for. So a big shout out to the both of you, and I will catch all of you in the next stream.